For the 44th problem on this first ACT practice test, the points E, which is located at 6, 4, and F, located at 14, 12, lie in the standard XY coordinate plane shown below. Point D lies on the line EF between E and F such that the length of the line EF is 4 times the length of the line DE. What are the coordinates of D? So basically what this question is saying is that we have this line EF, so E to F, and that there's some line ED such that it's only a fourth of the length of this line. And starting at point E, so we can guess that point D is probably somewhere around there. So considering that this problem is focusing on the lengths of these lines, that would be your clue to either use the distance formula to find the length or to redraw this as a triangle. And from there, you might know a trick so that you can easily identify this length. So I'll rewrite the distance formula, which you're more than welcome to use, but the way I'm going to approach this problem is redrawing triangles. So let me first rewrite the distance formula just so that you have it, if you prefer that method instead. So this formula is used to find the distance between any 2 points, x1, y1, and x2, y2. So you could replace x1, y1 with point E and x2, y2 with point F and just plug them into the formula to find the distance. But this formula can be difficult to memorize since it's a little bit complicated. Now, it does come from the Pythagorean theorem, and that's essentially what I'm going to use by redrawing this as a triangle. So let me do that. So I'm redrawing the line EF. So this bottom point here, this is E, and this top point here, this is F. But what I'm going to do is make a triangle out of this. So if I drop down a vertical line and I drop over a horizontal line here, what you end up with is a right triangle. So we just have to figure out what these lengths are here for the sides. So we know that E has an x value of 6 and F has an x value of 14. So if this is at 6 and this is at 14, then we know that there are 8 units between them. So we'll use the same type of argument, but now for point F and its y value of 12 and point E's y value of 4. So if this is at 12 and this is at 4, that would make this length here 8. And recall from a prior video that with this kind of triangle where you have 2 of the side lengths that aren't the hypotenuse equal to each other, we essentially have an isosceles right triangle. And if you know the sides, you can immediately find the hypotenuse, since it's just going to be 8, whatever this side length is, times by the square root of 2. And you can double check this with the Pythagorean theorem, but this relationship for isosceles right triangles, or for 45, 45, 90 triangles, since each of these angles here is 45 degrees, it's very helpful to memorize this trick going into the ACT. So now that we have the length EF, we can figure out the length ED, since EF is 4 times as big as this line ED. So in other words, the line ED will be 1/4 of this 8 times the square root of 2. So let's redraw that line, and just like we did with EF, we're going to make this into a triangle. And like I said, this length from E to D is going to be 1/4 of this length from E to F. And 1/4 of 8 times the square root of 2 would just be 2 times the square root of 2. Now, the important thing to recognize is that this line ED and this line EF would have the same angle with the horizontal. Or in other words, they would each have this 45-degree angle, which makes this angle over here for each of these triangles also 45. So again, in this case with ED, we have the case of a 45, 45, 90 triangle, or a right isosceles triangle. And with that being the case, if we know the hypotenuse, we can immediately figure out the legs. Since this is 2 times the square root of 2, each of these, since they're the same length, would have to be 2. And again, you can check this with the Pythagorean theorem, but it is indeed true. So now that we have all the sides of this triangle, and we know that E, as it's 6, 4, we can figure out what the points of D would be. Since notice, we're just 2 units to the right of E and 2 units above E. So point D would have the coordinates 8, since we're just adding 2 to each of these. So it would have 8 for its x, and adding 2 to its y would make it its 6. So 8, 6 is the coordinate where D is located, and that is choice letter G here.